Hello, everybody, and welcome to yet another week of distance learning. Woo! All right. Before we do anything else, we are doing a virtual spirit week, and today is Mental Healthcare Monday. So, to stay sane, what I like to do is a little bit of yoga. There's a lot of videos on YouTube you can just pull up and do like half an hour, 45 minutes, whole hour if you feel like it. It's quite nice. I can actually do this one now. I'm pretty proud of that. So who knows? Maybe by the end of the quarantine, I'll be super flexible, although pretty bad at flexibility. Now, on to some actual tech. Let's go ahead and talk about what are we doing this week. We're going to be taking a look at some simple circuits. So you're going to be able to tell me things about series and parallel circuits and calculate various aspects of them. And we're going to actually play around with a simulator where you can make your own. It'll be a lot of fun. First, let's talk about a circuit diagram. So typically, when you go to actually make some electrical component, you first want to draw what it's going to look like as a schematic. Now, normally we do 3-view drawings for things we're going to build, but for circuits, that doesn't make a whole lot of sense to do, because really what we care about is how are things connected to each other. So we'll do these top-down abstract designs like this, where you will represent different components using different symbols. So a battery will be represented by a long line and a short line. The long line is the positive side, the short line is the negative. Wire is just a line, the bulb can be this or some other squiggly thing. Resistor is any component that resists. So sometimes you might picture a bulb as a resistor, or a speaker as a resistor, or any other thing you can think of that uses electricity as a resistor. And a switch will be pictured just like so. This is a very simple switch. You have a different kind of switch. You'd still draw it like this on the diagram, even though it might look different in real life. Once again, anything that uses electricity could be modeled as a resistor, so don't just assume because it's drawn as a squiggly line that it's one of these bad boys, although these are passive resistors, and it might be one of these. Now, the thing to keep in mind here is charge is always flowing from high voltage to low voltage, so from your source to your ground. And we always talk about electricity going from positive to negative, even though in physics, you'll know, right, that electrons are the actual thing that's moving. So really, it's the other way around. The reason for that, again, we talked about this, is when they first discovered electricity, we did not know what was flowing. You have to have a closed circuit, so this is all review. Now, something to consider is there might be something called a short circuit that could develop. If you have a component you're trying to power, but you give electricity a different path to follow that has less resistance, that allows it to skip that component, the electricity will do so. This is a short circuit. So there'll be no power to it. That'd be no good. Something to watch out for. Ohm's Law, we've talked about a lot. Now, we usually talk about it as V equals IR, but it's just as valid to think about it other ways. You could think of it as I equals V over R or R equals V over I. And those might be helpful in these upcoming examples. So, the meat, the reason you all came here today. Let's talk about some actual properties of circuits. So we've talked about series and parallel circuits last week. We kind of described a series circuit as one where you have to go through a bunch of components all in a row, like this. Well, now let's talk about some properties that these kind of circuits have. One thing to consider is if any one of these fails, like let's say this component here stops working, no electricity can get through, all the components will fail. Just like a cheap set of Christmas lights. If you take out one bulb, the whole thing stops working, right? Another thing to consider is because these are all aligned together like this, you can actually treat each of these resistors as one big resistor if you're just trying to do some calculations to this circuit. So if you're just trying to do some math and you don't care that there are three of them, you could simply say this is just like having one big 3 ohm resistor instead of three 1 ohm resistors. So if you wanted to find the total resistance of a circuit like this, where everything is attached together in a series, you can just say total resistance is the same as all the individual resistances added together. Another thing to consider is this voltage here, 1.5 volts. What happens is we have a voltage drop across this component, and this component. How does that voltage drop happen? Well, we take some portion of our 1.5 volts and we distribute it across each one. So here, because all the resistors are 1 ohm resistors, the voltage drop will be the same. It'll be half a volt across each one. And if you add them all up, half plus half plus half, you'll get your original voltage. If these were different resistances, the voltage drop would be different across each component. The current, however, is always the same because there's only one path to take. So the current must be the same anywhere you measure inside this wire. So those are the kind of basic ideas behind a series circuit. Let's take a look at a parallel one. Inside a parallel circuit, there are more paths to go through than just one. So we could go across this path, or across this path, or across this path. Each one would be valid. So if you had a bunch of lights in a row, these would be much brighter than these. The reason being that if you think about this voltage, it's now got three possible ways to be distributed. So the voltage drop across each of these components will actually be 3 volts. 3 volts here, 3 volts here, and 3 volts here. The voltage drop is the same across any path. If we go through here and go back to the source, 3 volts will be going through, and same thing for all of these other paths. Now the tricky thing is what this means is the current might not necessarily be the same through each path. The current will depend upon the resistance. We'll know the voltage, since it'll be the voltage of our source, and we'll know the resistance, but to find the current, you have to apply Ohm's law. Finally, the total resistance is actually really tricky to calculate in this circuit. It's given to you by this formula. 1 over the total resistance is equal to 1 over each of the resistances added together. I'm not going to ask you to apply this formula, but it is something to note. It's very, very different from this really simple formula. All right, so here's a good summary of everything we've talked about. In a series circuit, the current is the same through all series elements. The voltage total for each drop added together gives you the voltage of your source, and adding the resistances gives you the total resistance. For a parallel, the current splits up, so that means the current is not the same necessarily. But the voltage drop will be the same across each component. And adding more resistors to this circuit will actually reduce your total resistance, which is kind of weird to think about, but think about it. The more paths you have to follow, the less resistance there will be because there will be more ways to go through the particular circuit. So there you have it. The power outlets in your house are connected in parallel to take advantage of this very fact. Now, something to consider is your assignment. It's going to be a little bit trickier, maybe not, than some of the other ones we've done so far, because it involves you actually having to do a simulation online. So if you click this link, it'll take you to this circuit lab. You can add things and connect them with wires and make them run. There's an introductory video in the assignment you can look at. It tells you exactly how to work it, but just want to make sure you guys all knew this is what it looks like. This is what you have to play with. All sorts of fun things down here you can connect to your circuit. Some of them work better than others. Maybe don't connect your hand would be my suggestion. At any rate, The directions are all there inside the assignment. So, this Sunday, the 10th, Simple Circuits assignment posted under Modules Distant Learning 4 is due. If you have any questions, please reach out. My email's right here. Happy to do a Zoom meeting with you. Stay safe, and I'll see you guys soon, hopefully. Have a good one.